65 degrees. Who has 60 degrees north land? How close are you?
45 degrees south is 2.97.
Yeah, no. What dinosaur embarrassed? Oh, because you didn't actually calculate it, you just saw it on my paper. You didn't actually calculate it? Why are you so sad? I see. It's okay. What about 30 degrees south land? Who's got 30 degrees south land? Who has 30 degrees south land? Okay. Are you guys getting there or not quite?
Yeah.
Getting there? So your job, students, will be to map this data, color-code it on your world map for your post-lab. And there's a few questions you'll have to answer. I'm sure you can see the post-lab when you get there. But already, we see a pattern. And take my word for it, you can assume that like 60 degrees south, 60 degrees north is a small number. Do you have that? Yeah, that's a little bit low. That's fine. It'll still show us what we need. That'll work. Look at this. Where are the highest diversity regions? In the middle. In the ocean. Yeah, the 30s. And the highest diversity zones on land are at the equator. On land, I think you already anticipated this. We talked about it. The tropics have the highest diversity. They're the most productive. They're the most consistent. And for people who've been to the ocean in the tropics, the shallow water sure looks diverse. Great Barrier Reef and stuff are in the tropics. What surprised everyone when this research was done a few years ago is that the most diverse parts of the ocean are actually not in the tropics. They're at the 30s. Would anybody like to guess why?
Oh. Upwelling, right?
Well, upwelling happens all over the world's oceans. So upwelling does give you more productivity. What else?
Is there some kind of tidal pattern, like a current that prevents things from being as diverse? Right?
Currents are involved. Yes?
Somewhat cooler water temperature.
The coldest water is at the poles, which is why those are the most productive. But that's not why they're the most diverse. As a matter of fact, the coldest water is the least diverse.
Yeah. Is it because, like, the species of fish and stuff, they migrate back and forth, making more species in that area?
You're probably the closest yet.
Was this study done over 1 year? Or just during 1 year?
Tell the truth, I don't remember that.
Okay, we're just going to ask maybe it was done during like an El Nino year or something.
If I remember correctly, I mean, I'm sure it was multi-years, but I don't know how the data was collated. But no, this was a huge international thing, so I'm guessing they average all those things out. Anybody else want to take a stab at this? It's the sort of thing the College Board loves to nerd out on, so. Does anybody remember what's going on? He's being all right, so back to me. Does it, yeah. Anybody remember what an ecotone is?
You have to make the massive ecotone. and the extreme color.
So here's the part that's interesting about the ocean. We usually think that when you mix hot water with cold water, you'll get, obviously, please give me a minute, warm water, right? The funny thing about the ocean is when you mix cold water and hot water, you get two different layers, the hot on top of the cold. At 30 degrees north and south, you have warm diversity on top of cold diversity. So it's a classic edge effect, an ecotone, where two different things overlap. What'd you get? 2 point what? That's a little low. I wrote 2.7 on